Lesson 6 looks at solving radical and rational equations. So we've spent time in this chapter learning how to graph them, learning how to identify non-permissible values. And what we're going to do now is we're going to actually look at solving the types of equations. So a radical equation is an equation that contains a radical. And when it says contains a radical, it means that the variable is underneath the radical. Okay, so having the square root of 3 times x is not a radical function. Okay? A rational equation is an equation in which at least one of the terms is a rational expression that has to have a variable in the denominator. Again, if it doesn't have a variable in the denominator, it's not a rational expression. Okay? Reminder, the value of the variable that satisfies the equation is called the root of the equation. So in this lesson, we're going to look at approximate solutions using graphing techniques. So if we fill in the blanks, this is kind of a review. We did this with polynomials as well. The blank of the function, the blank of the graph, and the blank of the corresponding equation y equals 0 are the blank numbers. So what are my blanks? The zeros of the function. What do we look at on the graph? The x-intercepts. And then the equation, we were looking at the roots. And what do all of these numbers have in common? They're all the same. So in physics, students were given a long piece of string and a weight and asked to create a timing mechanism. Courtney knew that if they created a simple pendulum, the relationship between the length of the pendulum and the time it takes for the weight to swing back and forth can be approximated using the formula T equals 0.2 times the square root of L, where T is time in seconds and L is the length in centimeters. So she decided to create a simple pendulum with a period of 1 second, meaning it would take 1 second for it to swing back and forth. Right? But do not solve a radical equation that could be used to determine the length of the pendulum. So my formula is T equals 0.2 times the square root of L. And what piece of information have I been given? Have I been given a length or have I been given a time? A time. And the time is what? 1 second. So I can rewrite this as 1.0 equals 0.2 times the square root of L. Now suppose I wanted to graph this radical function. And I wanted to be able to solve by using the x-intercept. So if I'm solving by using the x-intercept, that means that I'm finding the zeros on the graph. When I am looking for zeros, how many equations do I have? I'm looking for it crossing the x-axis, so I'm only going to have one equation. So I want to take this equation and write it as a y equals, which means I want to move this to the other side of the equation. So I want to rewrite the equation. So I let y1 be equal to 0.2 times the square root of L minus 1.0. And then I would use the zero feature to find the x-intercept. So I'll give you a moment. I want you to graph that. See what you're going to need to use for window settings. so that you can see the x-intercept. So the window settings you had to play with. Understanding what the y value and the L value stand for in the equation helps. L is the length of my pendulum. So if I had started off with a zoom standard at 10 by 10, it doesn't actually cross the x-axis, so I have to extend it. And I know I don't need a lot in the negatives because that implies a negative length. I don't have a negative length. And then my y values is the time. So when I'm looking at the time, what I'm looking at is really a couple of seconds because I want it to actually be equal to 1 second. So again, I don't need to go very high on my graph. So then to find the 0, second calc 0, and then I have to be on the left side of this 0 value, and then the right side of the 0 value. I want to make sure the arrows point to each other. When I'm on the left side, my y values will be negative. When I'm on the right side, my y values would be positive in this case. And I get a 0 of 25. So now if I sketch that, get that this equals 25. So the length would be 25 centimeters. So if she makes her pendulum 25 centimeters long, it will take 1 second for it to do 1 rotation. So if we look at class example number 2, we have another radical function. Partial radical function of y equals f of x with an integral 0 is shown. So remember, the zeros are the x-intercepts. So that means that this is an integer. So what does each tick mark on my graph represent? 1. So this tick mark right here would be at -2. So the 0 of the function would be -2. The root of the equation, so when does f of x equals 0, would be the statement when x equals -2. So the root is written as an x equals. And then it says, use the graph to determine to the nearest whole number the solution to the equation f of x equals 3. So f of x equals 3 means when the graph, or when f of x, which is my y values, is equal to 3, what is x equal to? So I look to see where it intersects the graph. And it intersects the graph at 7. So the solution to the equation f of x equals 3 is that x would equal 7. And then the root of the equation f of x minus 4 equals 0 would be finding f of x equaling 4. So then if I moved this imaginary line up to 4, check to see where did it intersect the graph, what would my y value be this time? Or sorry, my x value would be 14. So then I would get that x equals 14. Okay? In the next part it says, in each case, explain how to use the graph of y equals f of x to determine the approximate solution to the given equation and state the solution to the nearest whole number. So what does f of x plus 6 mean? What was my replacement? X with an x plus 6. And when I replace x with an x plus 6, what does that tell me to do to the graph?
6 units left.
Move 6 units left. Okay. So if I look at the 0 of y equals f of x, so the 0 of my original equation was what? What was the 0 of my original equation? -2. So if I move -2, 6 units left, where would I end up? -8. That would be the 0 of that new function. So if I look at 2, what are my replacements on 2? Ignore the 5. So actually what I'm doing in this case is I'm going to compare f of x equaling 5 to f of x minus 3 equaling 5. So what did I make for my replacement?
X minus, you replace x with x minus 3.
And what does that tell me to do to the graph?
Translate it 3 units to the right.
Okay? So now if I determine the solution to f of x equaling 5. So if I go back up to that graph, and I now move this line to 5, where does it intersect the graph? At how much? 23? So the solution to f of x equals 5 is that x is equal to 23. So the solution to f of x minus 3 equals 5 means I would move the solution 3 units to the right. So the solution to f of x minus 3 equals 5 would be what?
26.
26. Because I would add 3 to go to the right. Okay. The last example says, consider the following functions. I have f of x, which equals 2x minus 3. I have g of x, which equals x minus 1. And I have h of x, which equals x plus 5. It says, determine graphically the solution of the following equations to the nearest hundredth. So I have to set up these equations. What I have in this case is f divided by g of x minus 5 equals 0. So what is f of x?
2x minus 3.
And what is g of x?
X minus 1.
There's my equation. And then what I'm going to do is I'm going to put this equation into the calculator and find the 0. So when I put this equation in the calculator, I have to be careful. There's 2 ways I could do this. So the first way is if I type it in as I see it, I need to put in a double set of brackets to start off with. So then I open up the brackets, 2 of them. 2x minus 3 is the first one. And then I close one set of brackets, divided by, and I open up again. And then it's x minus 1. And then I'm going to close it twice. So the outside brackets keep that whole thing together as one unit. And then the inside brackets make sure that 2x minus 3 is done separately from x minus 1. And then I can put the minus 5. So if I start off with my Zoom standard, I can now see where my 0 is. That's the solution I'm trying to find. So it's this value here that I'm trying to determine. And what do I get when I determine that?
0.67.
0.67. because I think it was to the nearest hundredth, right?
Yep.
So 0.6 repeating, which becomes 0.67. The other way that I could have done this is I could have gone 2x minus 3 divided by x minus 1, and then I could have let y2 be equal to 5. So I could have moved the 5 to the other side and had two equations. Then when I graph this, what point am I looking for this time? Am I looking for the 0? Or am I looking for the intersection point? Intersection, because I have two graphs. So I'd be looking for the intersection, which would still be 0.67. It does, in this case, make a little bit more sense to write it as a y1 only equation because you're asked to find the zeros. So then it follows I'm finding the zeros. So I get that x equals 0.67. Okay, so then I have b. b says the square root of f of x equals g of h of x. So what would the square root of f of x look like? Square root of 2x minus 1. Okay. And then g of h of x means I would have g of h of x, which is x plus 5. So I have to do that one in two steps. So I substitute h of x in to the g of x equation. So now I've got 2x minus 3 equals, instead of writing x, I'm going to write x plus 5 minus 1. And what is x plus 5 minus 1 going to equal? X plus 4. So then this would become x plus 4. So now when I go to put this into the calculator, if I let this side be equal to y1 and this side be equal to y2, I'd be finding the intersection, and that would give me the solution to this equation. So I'll give you a moment to find that. So when you graph this, and you put this on a standard window setting, what do you notice about the two graphs? They don't intersect. So if they don't intersect, what does that mean? There's no solution. So this would be no solution. And we can be sure, or how could we be sure that these don't intersect? Well, this is going to keep getting bigger, but while the radical equation keeps getting bigger, this is still going to be getting more bigger, because more bigger is an actual word. It'll be larger and larger. And the graph does not exist for the radical function underneath the x-axis because I can't take the square root of a negative number. So I'll never get a negative y value. Okay? Okay, so then the last one. F over g of x. What would that look like as an equation?
2x minus 3 over x minus 1.
Yeah. And what would that be equal to?
X minus 1 over x plus 1.
Okay. So then put that into your calculator and find the solution to that one. So when I go to graph this and I put it on a standard 10 by 10 window setting, I can see an intersection point right here that I can try to find. But right here, these graphs, something is going on over here. So I probably want to move this over a bit so I can see if it's actually intersecting at that point. So I could change my window settings to maybe start at -15 and go to 5. because I know that that intersection point on the right-hand side was before 5. And when I do that, now I can see intersection points better. I could then adjust my window settings because it looks like the intercept here almost looks like it's at 0, and this one right here looks like it's at about 3. So I could even change my Y values instead of going from -10 to 10, going from -1 to 4, which could then open things up a little bit more. And now I can actually see intersection points a lot clearer. And then I can go my second calc intersect. So sometimes with these questions, you have to manipulate the window settings in order to see what needs to be seen on the graph. So what do I get for intersection points? What can x equal? -10.52. And what else? 1.52. Okay. The 1.52 is the one that you'd probably see. The -10.52, you need to look at the characteristics of the graph and whether or not it is going to possibly intersect. And I can use my table of values as well to help me with that. Mine's on auto right, or ask. So if I put it on auto, and then I look, and I start going up, what I'm looking for is right here, y1 is bigger than y2. And then right here, all of a sudden y2 becomes bigger than y1. So if y1 was bigger and then it was smaller, that means that at some point they had to converge. So that's what I can use the table to help me with. Okay, so your questions. Question number 1, 3, 4, A and D, and then 5,